Going live. We are live. Okay. Hi, everyone. Happy New Year. Sorry that there was a bit of trouble with the Zoom setup today. Let me mute my YouTube stream. Okay. So sorry for the delay. I don't know what happened, but Zoom decided to change some things on me and I lost my controls as a host. So I had to restart everything and it is what it is. But here we are. Very happy to start the speaker series for year 2022. It's the new year and we have an exciting lineup of speakers coming up in the new year. And we are starting with one of the bright speakers that we have lined up for this year. But before that, I would like to introduce San Jose Astronomical Association and what we do a little bit. So we have been around many years, and we have been very active in terms of astronomy, public outreach, and education in general. COVID changed things a little bit, and we had to adapt to it, of course. And this is one of the programs that was fairly easy to adapt. To just go virtual and reach out to more speakers that way as well, because before the pandemic we would only be able to invite people local to us, but now we have been able to invite somebody sitting in Arizona and other parts of the country, or even somebody from India. So that's been a great change, and we have been trying to go full steam, even with all the challenges in our way. But to be perfectly honest with you, it is a volunteer-run organization, and we need a lot of support from our membership. We do have a lot of members. What we could use is a bit more help, or maybe a lot more help to run the programs that we want to keep running for our members and even for general public, because most of our programs are really freely available to general public, such as this one. Like, there is no stipulation that you have to be an SJAA member to be joining this talk today. If you are a meetup member, you have the access already. With that said, organization like this doesn't run without a lot of help. So if you have interest and time, we would love to get your help. Reach out to, I'm one of the board members, but if you go to sja.net, you can find the rest of us as well. And just send us an email and jump in, and any little bit of help goes a long way. So just, I mean, our speaker today is also, I think she has a lot of experience with this kind of thing too. And I'll come to that in a bit. So that's just my pitch for SJAA. And I hope that works. So coming to today's talk, like I mentioned, we have an exciting lineup for 2022. And today's speaker comes to us from, actually, she's local. She's a master's student, a graduate student at UC Santa Cruz, but she comes from Republic of Kosovo, where she's the founder of Astronomy Outreach of Kosovo. And that's amazing, outstanding, really, because that organization is reaching a lot of people. As I understand, it's the largest organization of such kind in Eastern Europe. And maybe she'll tell us a little bit about that in her talk today. But the topic of the talk is about asteroids mostly. Her research is into that field, about hunting these down and how to use different techniques to do that. So let's hear it. Pranvera, it's all yours.
Thank
Take
you.
it away.
Thank you very much. It's nice to be here, and thank you for inviting me. I can't see all of you, but at least some of you that I'm seeing, it's nice seeing you. I wish this was in person, because I'm finally here in San Jose, and it's like my fate to be like this. But anyway, I would like to talk today a little bit about asteroids, as you mentioned, but my main topic that I will be focusing is on the outreach side and how we can bring the science and astronomy more to the public. And I think that's something that we all actually like to do and share. It's science to the public. Um, so I am from Kosovo, and I recently came here to live in the United States. I moved here in 2020 when the pandemic was going crazy. I was admitted in the graduate program here at UC Santa Cruz in the Planetary Sciences department. So I haven't done even one single day in person of school. So ever since I moved here, everything has been from my computer. So it's not that I've met, people or professors, or that I've met that many, made friends or something like that. It's been very awkward, but I guess this is something that everybody is facing nowadays, and I'm more than happy to talk to you about today's topic. Um, so I wanted to share a little bit of my slides here for all of you that never heard of Kosovo, and I wouldn't be surprised if you never heard, because there are a lot of people when I'm telling them that I'm from Republic of Kosovo, they have no idea where it is. They think it's somewhere in Russia or I don't know. So it's a very small country in Eastern Europe, in the center of the Balkans Peninsula. In fact, it's the youngest country in Europe because we got our independence in 2008. And if you ever heard of Kosovo, I'm sure you've heard of it because of the history that we had with the war when we split from Yugoslavia. That was 20 years ago. I was like 3 years old, but I still remember all the scenes. It was very difficult. But now we're a small country. We're trying to educate our young people and trying to get ourselves together, and we're doing all right. So as for Kosovo, that's where I grew up, and I lived my whole life until a year ago. In fact, 2 years ago. And what got me into astronomy, it's when I was a little kid. In fact, it was still the wartime in the late 90s. I was only 3 years old back then. And there was a solar eclipse that was happening. It was a total eclipse, but I don't think from Kosovo we could see the whole totality. I think it was like 95, 97%. But anyway, it was interesting because in Kosovo, there are no astronomers. There are not people that are educated about science. And it was interesting how people were panicking back then about an event like this, which is, just a cool event. In fact, we like to see things like that. But people back in the day, they thought it's something dangerous, or it would be like the end of the world, or all the conspiracy. They wouldn't let the kids to go to school that day, and it was just all weird as a little kid to me to see all of how other people were reacting to that. And I remember my grandfather took me and my family, and of course we didn't have telescopes and solar glasses, but he took a bucket filled with water, and we were trying to look at the eclipse in the reflection of the water. And he was trying to tell us that, hey, this is just a normal thing. It's when the moon, crosses between Earth and the sun, and it happens, a few times a year. It's nothing to be worried about. And as a little kid back then, it was very, very interesting to me. It kind of gave me that sparkle that got me interested into the sky, to know like, hey, there are cool things out there that we don't know about. And luckily, I was born and raised in a farm in the country, so it was away from the city, and I always had access to the night sky. In Kosovo, after the wartime, the country was pretty much destroyed, so even the electricity was not, in every place. And I remember most of the time in the evenings, it would be dark and there would be no electricity. So all we had were candles, so we could just go outside and you could look at the sky like a perfect Milky Way and all the stars. And unfortunately, we didn't have telescopes and other equipment, and we still don't have them. It's like it's impossible to walk in a store in Kosovo and let's say like, oh, I'm gonna buy a telescope today, because that's not gonna happen. But still, just sitting out there and looking at the sky, looking at, shooting stars, meteorites and stuff like that, it was just incredible. And I loved it. It made me feel very good. It's very peaceful. And I'm sure that's how most of us feel even now.
U2 song about Kosovo.
Sorry? Oh, I think someone left the microphone on. So anyway, I grew up and I went to school. I was always one of these kids who liked science, and I was kind of nerdy. Even when I went to high school, that's when social media became a thing in Kosovo. It was like 2010, I believe. And my English was not good. I gotta tell you that. I couldn't speak anything in English, but I figured in Albanian, in my native language, we do not have many books that talk about, planets or the sky or, anything related to astronomy or planetary science. And even in the school, it's not a subject that really gets a lot of attention. Maybe in the physics class, you would mention here and there something, but it's nothing really. And I always was sad about it. I had this big dream that to become an astronomer someday. And it was kind of sad because I kind of knew that maybe I will never be able to do something because this is what my country offers and it's impossible. And even my parents, I remember they were worried because they said, you're not going to have probably a future if you go into this. So at the very beginning, they were not very supportive of the chosen field that I had. So after, getting internet and all of that, I got to meet some people from other countries that are also in astronomy. And of course, I use Google Translate, believe it or not, to communicate with these people because they didn't speak any, Albanian, and it was terrible the way I was communicating. But that's how I actually learned English, by using Google Translate, by watching movies, music, and all of that. That's how I managed to learn English. Of course, I'm not perfect at it, but I can at least communicate now. And it helped me a lot because that's how I reached out to astronomers and other people with common interests from other countries. And then they helped me out by sending me equipment. I remember when this person from a neighborhood country, I think he was from Croatia, he didn't even know me at all. And he said, I'm going to send you a telescope. And honestly, I didn't believe it. And then he wanted to meet my dad in Macedonia, in another country, and he came all the way with a train. He gave him the telescope. And I remember I didn't sleep all night waiting for the telescope. It was a 3-inch Newtonian telescope, a really tiny one, but to me, it was like giving me the Hubble Space Telescope or something like that, because it just meant a lot. And I didn't know how to use it. I had never heard of a reflector telescopes, the way that you don't look from the end, but from the side. And it took me a while to figure it out, but I remember the first object I pointed at was the moon, and it just took my breath away. It was the best moment ever. So like that, I decided to take that telescope to schools. I was in high school back then, and then it was very interesting. I could see how students and how young children were reacting to that. They had never ever looked in a telescope. They had never seen the moon or any planet before, like the Saturn ring or Jupiter. And to me, seeing all that interest from people, it really got me interested to do something more than that. So when I went to university, to college, I couldn't study astronomy because we didn't have any astronomy departments, or the university doesn't offer anything related to that. So I decided to study geography. something that would probably approach to planetary science, always with the hope that someday I would go in a field that would actually be either astronomy or planetary science. So it was good doing geography because I got to take a lot of classes in geology and geomorphology, climate, all of that. So it kind of prepared me for planetary science. And then at the same time, I decided to make an astronomy organization because we don't have any astronomy organizations in Kosovo. And I thought maybe we need something like a small group, a couple of students who are interested. We have a tiny telescope. Maybe we can go out there and do some events. And we started doing some of these events, and we never actually believed that someday we would reach like 25,000 people every year with our events, and we would be recognized internationally. And after the international astronomy community saw that we're trying to do outreach, but we didn't have equipment, everybody decided to help. I had astronomers from the United States, from Europe, from Australia. Everybody was trying to send us either telescopes or mounts and books and eyepieces, and just so we could have a little asset to work with. So I wanted to share this photo because I love it. These are the telescopes that we have in Kosovo, and our entire country, in fact, depends on these telescopes because this is what we use to go out there in our events. And I remember in 2015, it was right after we founded the organization and managed to have a couple telescopes. You can see we have some solar telescopes as well. We decided to do an event because there was a partial solar eclipse. So we had 3 small solar telescopes. We put them and we decided to go in the main square of the capital city of Kosovo, where we could reach tons of people. And then later that day, we had thousands of people that showed up to our event. In fact, we had to call like a security patrol to just manage all the people. And we also announced we're going to give solar glasses for free because we had like boxes of solar glasses sent to us. And we just shared everybody's solar glasses, and it just turned out amazing. I was incredibly happy that we had even people from the government, from university, from any institution in Kosovo. We had even people that traveled from Albania, from Macedonia, because they heard that there are going to be telescopes in Kosovo, and it would be open to the public, and they just decided to come by. And I was amazed because we were just a few students doing all of this. We didn't have all the hands to manage all of this, and it turned out amazing. So ever since then, we never stopped. We have decided to go to schools, to go to other cities. Sometimes we just set up our telescopes like in a square, in a place where like restaurants, and the people go out to eat, and then they could just come by and either look at the sun, or during the evenings at planets and the moon. And to us, this doesn't cost anything, but the impact is what matters. The impact is so big because we're reaching like hundreds of students, hundreds of people. We go to so many schools in Kosovo, and just seeing students how they can't wait in the line to get to the telescope because they're gonna see the sun's explosions, or they're gonna see some craters on the moon, or the Saturn, or all of these are something that students like, and especially young kids are always fascinated with astronomy, and we always love doing this. And these are just some photos I wanted to show from our events. It's not that we have, like professional astronomers. It's not that we have very good equipment either, but at least we're using what we have to go out there and spread the word and let everybody know that astronomy is a cool thing. It's something that deserves to be studied, and it needs more attention. And we're just simply trying to popularize the science in Kosovo and to make a change. So sometimes I just, I share these photos just to let everybody know like what we can see from the telescopes. Of course, I use this in Kosovo mostly. I know most of you probably have telescopes because um, when I first came to United States, I was invited to Texas Star Party to give a talk, the largest star party in the United States. And it was my first time to come to United States. And I remember walking in the fields, it's in the West Texas. There were like 3 huge football fields full of telescopes. I mean, I'm talking about 20 inches, 25 inches, 30 inches. And I remember walking by somebody and I said, "Oh, wow, your telescope is really good." It was a 25-inch. And he pointed out to me, he said, yeah, but I think I'm gonna sell it because it's not very big. He was complaining about it. And I was like, dude, I mean, the largest telescope in Kosovo is an 8-inch, and you're complaining about yours. So to me, it was like coming in a candy shop or something, because it was really, really amazing to come to see all these equipment at the same time. And and also I got to travel in other places in the United States and also in Australia. So my program was literally not just having an impact in our country, but it was also doing an impact internationally, because we we started something very small and we were inspiring so many. So people wanted to invite us to give talks to other countries to show them that we can do anything. Even, nothing is like impossible. We can start from very small step and we can reach up to something. And simply just to share our story, to inspire other people. And this is what helped me to also connect with a lot of astronomers, to connect with a lot of universities and schools and astronomy organizations. So I've been very happy and thankful to everybody who has been supportive all these years of me and my program. So now I'm gonna go ahead and talk a little bit about asteroids and why I actually like to research asteroids and minor planets. When I say, the question why asteroids, it's because I think these are, objects in the solar system that can tell us a lot about planets. I mean, they were leftovers of, from the formation of the solar system, and they hold a lot of questions to the history and evolution and the chemistry of the solar system, because after all, that is like the building blocks of our planet and other planets, and we can learn a lot from them. And I like to look at them. I like to try to study them. Even here now, after coming to UC Santa Cruz, I like to do a lot of research on asteroids. The other thing why I like asteroids and I like at least keeping an eye on them is because we know that these bodies sometimes could be potential threats to our planets. We haven't had any in our lifetime that actually was a huge threat, but we know that something like this wiped out the dinosaurs 65 million years ago. And of course, we don't want to end up with the same fate. At the same time, we know events like, I think you remember Chelyabinsk a few years back in Russia, when, a lot of people were injured by a pretty, considerable size. I don't think it was that big meteorite that hit, and all the shock wave that broke windows and people were injured. And that, in fact, tells us how serious it's to keep our eyes on these objects and to look that if something could possibly be a threat. And I started getting interested in asteroids when I first had my trip to Australia. I met some astronomers there. They had their own observatories in the backyard. And what they were mostly looking at were occultations, when an asteroid occults a star, and they were measuring the timing and then finding the shape of the asteroid. And I was fascinated by that. I never had heard of that before then. And it was just incredible how amateur astronomers from a small telescope can do things like that. can look at these things and can make reports and can help the Minor Planet Center to refine, orbits and to track down these objects. I was very fascinated. And of course, from Kosovo, I couldn't do a lot of things because of the lack of the equipment I had there. It was really impossible for me to ever do anything. But after starting traveling to other places, especially here in the United States, most people that I know have very good telescopes or observatories, and that gave me access to using better equipment and looking at these things. Recently, I started using SLU robotic telescope service. If you haven't heard of it, it's a platform online where you can log in and use telescopes. They have telescopes based in the Canary Islands and in Chile. And I think it's $100 per year and $20 per students per year. And you can use these telescopes all the time. And it's nice because you can also cover both hemispheres. You can look at objects in the southern hemisphere without even being there. So I use these telescopes to sometimes track minor planets, asteroids. These here in the animations that I took are known asteroids, and they're pretty big. So it's nothing, special about it, but I just like to share this sometimes with the public, especially like when we look at these things, it's kind of hard to, when you just take one single photo, it's hard to recognize which one is the star or which one is the asteroid unless you take multiple shots and then you put them together and then you blink those images. And then you see what is moving, because of course the asteroid is much closer to us than the star. So we're going to see the asteroid moving in the image. This was a near-Earth object that was moving very close to Earth. It was closer than the moon, if I'm not mistaken. And it was sometime last year, actually in 2020, it was the pandemic. But it was actually the first minor, near-Earth objects that I was able to capture. And of course, there are people who do this constantly, even from SLU, but all other observatories, and they're trying to find these objects and not let them surprise us, and then trying to calculate their orbits and see if maybe in the future they could be a potential threat to our planet. I'm sure you saw the movie Don't Look Up, probably. This is Hap Griffin, is a very good friend of mine in South Carolina, and Hap and I have done a lot of work together. He has his own observatory in South Carolina. This is a 12.5-inch telescope. And every time I visit him, we like to go ahead and look for objects that have just been reported, like they're still not confirmed as discoveries most of the time. And then once we take our observation, we put it in Astrometrica, we calculate the orbits, the ephemeris, and then we report it to the Minor Planet Center. And of course, when many people do that, it's very good because then they have a lot of data to work with. So then we can know more about the orbit of this particular object. So Astrometrica is a very easy software to use. I learned how to use it a couple of years ago, and I still get to learn it every day because it's a very nice program, has very good features that you can play with. The coolest thing I like about it, because it's very easy, you can snap photos, you can put it in the program, you can blink the images, and then they have like a database that you can download from the Minor Planet Center with all the known objects, minor planets that we know so far. So when you put an image in there and you're looking for, you see something moving in the image, and if the database doesn't recognize that object that you found, it could probably be a new object, and then you report that to the Minor Planet Center, and then someone else will look at it, and if they also find that to be a new object, then they will name it or declare it as a provisional discovery of a new object. So last year or 2 years ago, we were looking at this object they just reported it in the Minor Planet Center section, and somebody had found it. One person had found it, and then nobody had confirmed for that object. And we were about to close down the observatory because it was a full moon. It was pretty high. And I was like, let's just try this one more time. And then we pointed at this object and we actually found it. It was a comet. Somebody had found a comet, but it wasn't sure if this is a comet or not. So we found it. And in fact, you could see a very little tail. So we reported this. And after some other reports that were done from other people also, this was confirmed to be a comet, and it was named Comet Atlas, that became visible later in the year of 2020. It was supposed to be very bright, but I think it was destroyed when it came closer to the sun. But it was very nice because we were like the first people to actually look at this object, among the person who found it, and then confirm for him that this actually was a new discovery. It was a comet, and it was super cool. In fact, Hap later on, when it became more brighter, he took an image of it, and it was very special to see it because we had made a report for this object months ahead. Other things that I've been working on is the International Astronomical Search Collaboration. I'm not sure how familiar are you with this campaign. What they actually do is they're trying to get the public more involved in projects for looking and hunting, chasing minor planets. What they do is the Pan-STARRS telescopes, which is a 1.8 meter telescope in Hawaii. They use this telescope to scan, the sky, and they take so much images that of course, the professional team, it's not capable of analyzing all that data because it's a lot. So they are trying to bring more people to working, with them and analyzing the data, and of course, getting the public excited about searching for new minor planets at the same time. It's a very cool campaign, and I've participated in it 2 years ago, and also I am participating again this month. And every week we are sent new data in the account that we form, and then we usually analyze these images. We literally have to go in every corner of the image and see if there is something moving or not. Sometimes there are objects that are moving, but they're previously discovered asteroids. Sometimes there could be a bad pixel. Sometimes you have to know what you're looking for. But after a while, you somehow get used to using this program. And it's very cool because everybody can do it. I know there's a family from somewhere in the Middle East. It's like a dad, his wife, and the 4 children do this, and they discovered 14 asteroids by analyzing the data from Pan-STARRS. And there are, if I'm not mistaken, 180 groups around the world from every country. There are students, high school students, family members, anybody that can participate. And the cool thing about it is that if you discover something, you will be able to actually name the object and you get the credits for the discovery. And I like it very much. I think it couldn't be any better program to get the public excited about science. So I think this is supposed to be an animation, if I can play it. Maybe not. I don't know. I thought this was a video. I'll pass it. This is how is it a report, for example, when we see something, we can just give it a temporary designation. When Hap and I were looking at this data for a period of a month only, we found 27 objects that we reported that the database was not recognizing. But this doesn't immediately mean that all the 27 objects are new discoveries. Of course not. They have to go through another set of analysis from the professional team, and from the 27 objects that we reported, only 10 of them fulfilled the criteria to be studied further. And then from all of those, only one of them got to be a new object. So we actually discovered a new object last fall, and it was, this was the video that I think I was trying to show earlier. Still, it's not playing. Sorry about that. But that object that we discovered last fall, it was given a designation of 2020, whatever. It's still not, we still cannot name it until we have another report from someone on this asteroid. But the problem is that this asteroid is a 25 magnitude, which is almost impossible to get it from the telescope that HAP has, or someone that we know have, that can see that dim objects. And I keep saying last fall, but this was in 2020 because I forgot that we're in 2022 right now. And of course, this is how the ephemeris for this object look in the Minor Planet Center. But the cool thing about it is that you don't have to become a professional astronomer to just have the chance or the opportunity to see or discover something in the sky. You have campaigns or programs like this that you can go ahead, register for free, and you can analyze the data. You can learn how to use the softwares, which is very, very easy. And you can discover things from your own computer. Now, how cool is that? And I love doing this. Hap and I are still doing this. Even now, every week we report new objects. It's very exciting. So when we discovered this asteroid, this is where the position was in compare with Earth. And this is where it is right now. So it has moved kind of far away. And in 2024, it will come again in the closest point with Earth. So hopefully then we will be able to see it from a considerable, telescope. So in 2017, I was lucky enough to have one of these minor planets in the main belt asteroid named after my name. I love minor planets, and I was very excited when they announced it. So what actually interested me most was studying this object a little bit closer, not just because it has my name on it, but I kind of like looking at it from the telescopes when I can, and just sharing it with the people in Kosovo, photos of it, because I find this to be a very inspiring thing from the children and from the young generation in Kosovo. So this is actually the first time I got to see it from a telescope in Argentina, because from Kosovo, it was impossible for me to see it with my telescopes. So I happened to be in Argentina for a solar eclipse event. And this is my good friend Cesar, who showed me that from his telescope. And you can see my face. I was all over the moon. I was super excited about that. And then this is the first time I actually got to image it through sleuth telescopes, as I mentioned earlier. I used the 17-inch telescope in the Canary Island, and I was able to see it. And the cool thing about it is that when I tried to find it in Astrometrica, the database, of course, recognizes the objects. The residuals are like spot on, 0.00. And of course, it shows my name in there, and it's always so inspiring. It always inspires me. So not only this, I've been trying to study this asteroid a little bit further. I wanted to know what the composition of it is, what we can learn about the periods of rotation. And some of these things, of course, I couldn't do by myself. So I asked for help from other astronomers. Last month, I reached out to some astronomy group in Southern California, and they managed to make a light curve of this asteroid. So this was over a period of 5 days, I think. And this was separated data, but then they merged it all together, and they came up that the asteroid is actually pretty slow for an asteroid. It's only like 17, I would say 18 hours a period of rotation. I always imagined it could be way, way more faster. And last month, also, I got to cooperate with some astronomers in the astronomy department here at UC Santa Cruz. So this is a research team looking at galaxies billions of light years away, and they're trying to measure the spectra, the Doppler shifts, and all these cool stuff. But then they said maybe at the end of the session we will be able to point the telescope. This is the 3-meter Shane telescope. I can see it from my porch. It's really cool. They said maybe we could point the telescope to this asteroid and we could take a spectra of it, the first spectra ever. And when they did it, it was so cool. And we made this a public event. They call these the Shadow the Scientist. Everybody can participate and engage with professional astronomers as they operate these large telescopes, sometimes Shane or Keck telescope or Subaru. And then this was when we were looking at the asteroid. It was the end of the day. It was almost morning time. So this is the slit of the spectra, the spectroscope. And this was a star. And then this was the asteroid, like right next to the star. And the cool thing is, like, we could actually see in a period of 30 minutes how the asteroid was kind of shifting, drifting towards this upper star here, and they were following with a slit. So this is how the spectra was looking like the raw spectra when they were taking it, all the softwares, which I don't understand because I don't manage those. But then yesterday, Professor Raja from the astronomy department, he sent me the process data of the asteroid. And I was so excited. In fact, I haven't had a chance to look at it yet, to analyze it, because he just sent it to me last night. But it's cool because they take the spectra of the asteroid, the reflected light from the surface, and then they take a spectrum of the sun, and then they try to subtract these two, and then to see what we're left with, what spectra for the asteroid. So I don't know how much I can learn about the composition of this asteroid through this spectra, because it was taken in the visible light. And most asteroids that are studied through spectroscopy, they are trying to drift more in the infrared. They're especially around like 3 micron. They try to look for like water feature or like, carbonates and other stuff. So I don't know how much this will be helpful, but it was a very, very good experience and a very high privilege for me to be able to take the first spectra of an asteroid that actually holds my name. And I really am happy about it. And in fact, I'm thinking of continuing my research in focusing more about spectroscopy of minor planets and understanding not just the main belt asteroids, but also the Trojans, the trans-Neptunian, centaurs, all these objects that we know very little about, to be able to study them. Of course, it's impossible to send a space mission to every asteroid we know, because there are so many. So our only left option is like studying them from the ground, and we have fascinating telescopes all over the world. And this could be something really cool to focus my research, and I'm happy to do it and share it with everybody else. This was just an animation. I don't know if you can see it, but I put my mouse in there. So as for the end, I just wanted to share like my ongoing efforts, despite that the graduate program is keeping me pretty busy with all the classes and research and all of that. At the same time, I keep my eyes back all the time in Kosovo. I'm trying to work out with a team. I am not there all the time, so it was kind of hard to just move over here and leave everything behind back then. But we have an incredible board back home that they're taking care of everything. They're doing events, they're going to schools, and all the telescopes that I have, I left everything in Kosovo because I figured they need the equipment more than I do, and they're using them and doing an amazing job. So lately I've been trying to convince the government to to build the first observatory and planetarium in our country. And after 2 years of back and forth with the government, because it's not easy to convince politicians to do anything about science, but I finally, me and my board, got the government convinced that we definitely need an observatory in Kosovo. And they promised that we're going to start the building in the spring of this year. And I hope it's going to happen, because I'm very excited. And also Celestron, the company, they have donated a 14-inch telescope that will go in the observatory. And there are other astronomers who have donated equipment that will go in the planetarium. And this will be more like a small science center, I would say, where the public and the schools and other visitors would be able to come in and observe, have a planetarium show, learn about science, meteorites, and everything that we can possibly offer, because we have never had something in Kosovo and we want to bring it. I mean, I come here in the United States, and in every city you go, they at least have a museum or a planetarium or something for astronomy or STEM and science. It's very nice, and I want this to change. I want that when people go to Kosovo and say like, oh, today I'm gonna go and have a planetarium show. I want this to be possible for the people in Kosovo. I myself never had enough planetarium experience until I actually left the country and went to Australia and then saw what the real planetarium actually is. And I want our people, our nation, to have the same opportunity, to have the same experience. And I'm looking forward to this, because this is my dream and it's a big thing that it's gonna happen. So even after coming here, I kind of wanted to do outreach. I know that, astronomy is very common here and people can go anywhere, but it's in my blood to go out there and share science with other people. So somebody was kind enough from Florida to donate me a telescope when I moved here, because I didn't have a telescope. It's like a C8 Celestron. So one day I decided to get my telescope and go to Santana Row and just put it there and welcome people to look in the telescope. I don't know if anyone from you have ever done it, but I went to Santana Row many times. I saw how many people go there and they walk around, and it's, I think, the perfect place to go and do an event, because you don't always wait for people to come to you. You are the one that should go and reach the people, because they are not going to know about you otherwise. So every time, everywhere I go, I try to reach people and to be among people so they could look at the moon or the Saturn. And that's how it starts. That's how I started. And that's how it goes. Then a kid looks in your telescope, and the second thing you know, it's going to become like you're going to see him on TV talking about planets and all of that. It's very inspiring. And I was very happy to have firefighters, to have children, other people to come look in the telescope. It was very exciting. It was my very first outreach event outside of Kosovo with my telescope. And of course, I was luckily traveling a lot last year, despite the pandemic. I went to Middle East and other places, so I was able to connect with other astronomy groups. We did events like this together. We did one in Dubai. It was very interesting because the light pollution is horrible there, but that doesn't stop us from looking at planets or the moon. So anyway, this is my story. This is what I wanted to share, and I just want to get the word out there and to also applaud most of you, because I know most of you do the same things. Most of you like to share astronomy with others in all kinds of ways. Someone likes to do astrophotography and share them on Facebook or social media. Someone likes to take the telescope out to the public. We all have our own techniques, and I appreciate everyone who does that. And we need more people in science, and we need to inspire more people about science, and just keep doing the great work. So thank you, everyone. And if you have any question, please feel free to ask. Thanks again. I think I will stop sharing my screen because it's not necessary.
Wow, I'm gonna go first. That was, I mean, inspiring is an understatement. I mean, really, thank you so much. That was phenomenal. And just two things before we get to the questions. Your English is really good. Okay, I come from another country too. I understand what you mean when you say you had to learn English all over from scratch. No issues there. And secondly, you didn't, an asteroid wasn't named after you by luck. It was all your hard work. So just, appreciate that for yourself. Like it's just great. And this is an interactive meeting, so it's an open forum. If anybody has any questions, you can unmute yourself and ask the question, or you can type it in chat and I can relate to Pranvera.
I'm just checking in the chat now because I was unable to see it while I was talking.
Yeah, no, that's expected. That's fine. It's my job to monitor that. So I'm here for that. So whichever way you want to do it, we can do it. I'm also monitoring chat and YouTube, but I don't see any questions coming in on that one yet. And I'll just kickstart with one question I have. So currently you're pursuing a master's degree. Do you have plans of going for a PhD and continuing your research?
Yeah, I didn't talk a lot about it. When I was admitted at UC Santa Cruz, it was like my dream came true because I never really believed I will have the chance to go in the field that I am interested in. So I was very, very happy, and I felt very lucky that I was gonna go to UC Santa Cruz. And in fact, I anticipate graduation of my master's degree this March. And I already submitted my application for PhD last week.
Great,
so
great.
I'm hoping to go, again, it's the same department, same field. So I hope I will have the same luck again. And
great.
Yeah.
And is it with Professor Raja? We have had him give a talk for us. Maybe
actually,
2-3 years ago.
Raja is in the astronomy department, and I am in the planetary science department.
That's right. Okay. Okay.
I connected with Raja just through outreach. I was given a talk, and he saw that, and that's how we interacted and started working together. But yeah, he's a very good person, very supportive of my work as well.
Yep. All right, I will open it up for others now to ask questions.
Yeah, I actually had a question or two. The SLU, can you all hear me?
Yes, yeah, we can hear you.
The SLU program website, I looked at that. Is that the only option I saw immediately that presented itself was an option to log in or create an account as a teacher?
I think you can. 1 second. In fact, I'm just gonna share my screen, and you can see this is SLU. As for opening an account, I'm not sure how many options they have. I know they have the astronomer option. It's more expensive. They have the student option, and then they have just the normal one, which is I think $100. So for that, I would have to ask SLU. But this is when you log in the SLU software. These are where all the telescopes are. So they have Chile 1, I think it's a 14-inch, Chile 2 a 17-inch. Then they have the Canary ones, the 20-inch, 17, 14, I think 14 and 11. So actually the ones that are with the green are online right now. So we can see what this telescope is looking at. It shows you that this Canary 2 telescope, it's looking at this object. You can see it's pretty lame right now if the view is not very good, but you can see what objects are going to be next. We could perhaps go to the other telescope and see what they're looking at. I don't know if the view is going to be any better. Of course, the M44. This is a large break. So it's coming up. So this telescope, it's looking at the Heave star cluster. So this is what they do. And then they have a lot of clubs. If I can find them somewhere here. The clubs that they have, I like very much. They have a Comet Tracker Club. They're like the club that all they do is like track comets. They have one only for near-Earth objects. And the cool thing about SLU is that they have a team that will train you to use Astrometrica so precisely that then you can use the SLU code, because to be able to report anything to the Minor Planet Center, you have to have an observatory code. You can use their code and submit observations of your own that you took from SLU. It's very cool. And then people just take, images and all of that. But where is it? Galleries. Here are like just images that I've been able to take from SLU and just share them with people. I am a lousy astrophotographer. I don't go taking a lot of photos and stacking them and all of them. All I do is like just take a single shot of whatever the telescope is pointing at and just, post it. So most of these are just raw images that I just took from the telescope. This is like the Horsehead Nebula. And these are things that from my telescopes, I was never able to take images. And I find SLU to be very cool. And the coolest thing about SLU is that you can have it in your phone. You can be in the train, you can be, outside, you can be anywhere. Just log in and point the telescope wherever you want, from your phone, from your computer. Even if it's daytime in your place, the Canary Island could be night, or in the Chile because of the different time zones. Sometimes when there are like phenomena like eclipses or the passing of a NEO, they stream it, so you can be able to go there and snap your own photos. I like SLU. I think it's a very easy tool to use, especially for people who don't want to spend money and buy big telescopes, because astronomy is a very expensive science, of course. Yeah, so if anyone wants to use SLU, it's a great tool. So I think you also saw the website slu.com. Okay, I hope that wasn't too long.
Is there any noticeable difference in composition of the asteroids between ones that maybe have irregular orbits and ones that have more standard orbits in the asteroid belt?
Well, you're saying about the orbits. Are you talking between like the main belts and the NEOs, or how do you mean?
Yeah,
Well,
I think that would summarize that well.
I wouldn't separate asteroids like that. For example, the asteroids could be different if they're like in the main belt. They could be the Trojans, which are in the Jupiter orbit, or the Trans-Neptunian, which are like past Neptune and Pluto in the Kuiper belt. Because everything that forms further from the sun, of course, when the solar nebula was back in the day, all the gas was blown away further from the sun, from the solar wind. That's why we have the gas giants and the Neptune and Saturn and all of these back way, because all the gas was somehow transferred there, like all the hydrogen and all of that. So, and then we have the snow line, between Mars and Jupiter. Like the snow line, it's where it kind of, it falls in the asteroid belt. So we have asteroids of different classes. Some are like classes S, that I think are like from metals and silicates. And then we have asteroids that are primarily like made of carbon and ice, that are a little bit further. And these are like the C types. And then of course the Trojans and Trans-Neptunians are primarily made of ice, because they're like really far away. They didn't experience any melting or heat, so they're somehow just frozen like that. In fact, one of the topics that I'm researching right now are the carbonates on some of these asteroids. Carbonates happen when an asteroid had like fluid water running in the asteroid, and it has like aqueous alteration it had in the past, and that's what forms the carbonates, like what is it, calcite or dolomites and all of that. And the interesting thing is that when asteroid Bennu, that they took some samples from, that is a near-Earth asteroid. When they looked at it from the spacecraft, they saw that the asteroid Bennu had very large carbonate veins in the surface, like a lot of them. So they're trying to study that. I would say that these carbonate veins form when an asteroid experiences some heating, some, I wouldn't say melting, but some heat to make the water melt, the ice, of course, melt and then run in the asteroid. And that's what makes the aqueous alteration. So it's a lot of things that, characterizes the asteroids. Not all of them are made from the same thing. Some are like differentiated, some are not. Some have, like, for example, Vesta has like a core, has layers because it's bigger. It had more rare earth elements probably that caused the decay and then heating and all of that. The aluminum 26, and then the smaller ones are so small, and then the heat escaped so quickly, so they couldn't have a lot of heat experience. They didn't experience a lot of heating, so that also makes it, all the whatever composition that it has, it doesn't change because it didn't go through anything. So I hope this answered a little bit my question. That's what I'm in fact trying to study, to study the difference, the different asteroids in different orbits, depending the distance from the sun and what compositions they have. I assume that according to the albedo of the asteroid that holds my name, it has a 0.06 albedo, which means it's very dark. And that would make it probably a C-type asteroid because it's a carbonaceous asteroid. The carbonaceous asteroid tend to look very dark, like asteroid Bennu. So yeah, these are just some things that I look at, and yeah. But if anyone knows something, please feel free to add and fulfill the answer a little bit more.
This isn't really a question, but I might say that for the observatory in Kosovo, might need more than 3 parking spots, non-handicap parking spots, hopefully.
I know this was the architect. In fact, it was very tough because the architects that we were working with, they are from Kosovo. They have never seen an observatory before. So designing an observatory for them, it was very tough. So I had to go back and forth with international astronomers and people who have observatories, and then with the architects, and see what and how we can do it. And there are a lot of astronomers that gave me tips as to what to do and what to not do in the observatory. For example, when you put the telescope in the observatory, you make sure that the tube that is in the middle, it's not connected to the floor to not cause any vibrations, and things like that, small things, but that could mean a lot in an observatory. And let's see how it goes. I hope someday you will be able to visit us over there.
That's a very inspiring project too. So speaking of observatories, you earlier showed a picture of this observatory on the Haleakala summit. I was there recently, but it's never open to public, right? Like we tried to find out, but
which one?
The one in Hawaii on Haleakala summit.
The CAG telescope?
The Pan-STAR, I think.
Oh, the Pan-STAR is okay. I'm not very familiar where it's located in Hawaii.
I see. Okay.
I just know all of them are in Hawaii. That's cool.
Yeah.
So yeah, I have never been there. I know people that work there, so I don't know how the public visits actually are operating in there. I don't know.
Yeah, I think it also has a naval observatory and things like that. So I think they don't allow people there, similar as they do at Mauna Kea, which is on Big Island.
But speaking of Lick Observatory, you showed the Shane telescope, and you mentioned that they have this program called Shadow of Scientists. I've never heard of that. Can you
Yeah,
talk a
the
little bit
Shadow
about
the Scientist, it's not from Lick actually. It's
Oh.
in fact from Raja, Professor Raja and his research team. What they decided to do is whenever him and his students are working or looking at galaxies and whatever they're researching on, they use the telescope. Sometimes they use the 10-meter Keck telescope, sometimes they use the Shane telescope, sometimes the Subaru 8-meter telescope that they used in the Don't Look Up movie. And what they do is all the research team connects on the Zoom, and then they invite people from all over the world to join in the Zoom and just be there and watch as astronomers, I mean professional astronomers, run these observatories and these telescopes and how they are obtaining the data for their own research. So Raja does these very often, and in fact he has got more other professional teams got into them that they're also doing the same thing. Last week or this week, in fact, in Monday and Tuesday, we had 2 events, and we had people from all over the world, like 170 people, I think, that joined over Zoom. And then the professional team was looking at galaxies, a group of galaxies that they were trying to measure the distances and looking at their spectra and all of that. And at the same time, the public was looking through Zoom just like that. They share the screen, and then you can ask any question regarding astronomy, and the professional team will be able to respond to your questions. Most of the time, they are happening during the night in Pacific time, because they're either in Hawaii or here, so they're using like all night to look at the sky. But of course, for other countries like Eastern Europe or Australia and other places, it's like daytime and they can connect. We had a school from Kosovo with 60 students that connected the other day, and the questions the students were asking were like, the research team literally was not having all the time to answer all the questions. They were asking about dark matter, about black holes, about things that honestly, even myself, I cannot answer because I'm not into that part of astronomy. But it was very nice. You know, it's an outreach event. Nowadays, we're doing everything online, so it works very well. And next time they have something like this, I'll make sure to send you an invitation.
Oh yeah, that would be perfect. In fact, so I have some questions in the chat from David. One is, how do you sign up or get on the mailing list for this Shadow of Scientist program? And another one is,
on the mailing list, I would have to ask Raja, how do you get in the mailing list? Usually what we do, he tells me that we're having an event, and then I just share it on social media, and then everybody who has connections to me will see it, and then they will notify somebody else, and that's how it works. But
I see. So it's
I'll
word
be
of
sure
mouth.
to ask Raja, and we'll let you guys know, of course.
Yeah, you have my email. Just let me know, and I can forward that information on Meetup and our members, to our members especially. And the second question is, are you taking donations? I expect this was with regards to your astronomy organization.
Yes, we do. Unfortunately, PayPal and all of these, they don't work in Kosovo. So previously from other organizations, we have received checks. The GoFundMe that I made here, I did it for the observatory, but now since the government has agreed to build the observatory, we are not using GoFundMe anymore. So if anyone wants to send a donation, we accept checks, and then I usually get the money either in person or via like Western Union and stuff like that to the organization.
I see. Okay, got it. Well, that's great. Another compliment for you. Somebody from Switzerland is watching around, and it's 6 a.m. there, and they found it totally worth it.
What the heck? Wow. Thank you for watching, everyone. I forgot that we're going live on YouTube.
Yeah, I actually don't, like, I can't tell by the username who it is. It's just Rodriz.
Yeah, I think I know. It's a friend of mine.
I see. Okay.
Cool.
It's pretty cool. Yeah.
I wish this was in person so I could actually meet all of you, but I hope
I
someday
really wish this
when
was in person too. Really, I mean, I could talk to you forever. Like your passion for outreach is very contagious. I mean, we need these things to be contagious, not Omicron, right? But that's what we are stuck with right now.
I hope when you guys are back in person, you will let me know so I can join one of your
I
meetings.
will definitely let you know, and we would love to have you back. And I mean, all those pictures you shared, we do all of that. We set up telescopes and get a lot of kids, and that's what I find very amazing about this hobby too. Like, I mean, when you were talking about your outreach in Kosovo, I was reminded of starting out, you know, as a teenager back in India and with my organization there, how we used to do outreach with like limited number of telescopes we had there. And here we have more advanced things available, fortunately. We just hope we can go back to sharing those with the general public and a lot of kids to generate interest. So
let me ask a question to all of you. How often do you do outreach events? And when you do outreach events, where do you usually do them? Do you visit schools?
Yeah,
Do you go
so
to,
we do.
public squares?
Well, I have to say we used to do all of that, and like this ties back a little bit to my pitch in the beginning that we really are looking for help right now. So if you feel the same passion that Pranvera has, please consider helping out with our programs. So we do have a school star party program, which is currently on hold because, you know, of the fear of spreading the virus.
Yeah.
And schools are not in person right now, like in most places probably too, right? So we do have that where we would go to the schools, do an astronomy program for them on weeknights mostly. And maybe Joey here can speak a little bit about that. Then we have something called as ITSP, which is In-Town Star Party. And that used to happen at our base camp in San Jose. There is this public park called Hoagie Park. That's where we used to meet. We still have the building, we just don't have access to it right now. It's owned by City of San Jose. So we used to do 2 star parties there every month. So we had events happening every weekend, basically, like it's that frequent. Like all those are outreach events, basically. And then those would happen on the first quarter and the third quarter. And then on the third quarter, we also did another star party called Starry Nights in collaboration with Open Space Authority of Santa Clara County down in Morgan Hill. And that got even more turnout of people. I think we have had as many as like maybe 300 people come one time. I think it's just phenomenal, and much darker skies than what we can show from San Jose, obviously, with the light pollution. And then we have the speaker program, which used to be in person as well, right after our board meeting every full moon weekend.
Where are your facilities?
In San Jose. Yeah, the same Hoagie Park location that I mentioned earlier. So we used to meet in there.
I haven't noticed there is a planetarium downtown somewhere when I passed.
Oh, we don't have a planetarium. We just set up a telescope.
Who owns that? Not your organization?
No.
Okay, all right.
No. So yeah, I mean, those are just few of the examples. I can go on and on. I don't want to keep everyone, but like we also have a fix-it program where people can bring in the telescopes to get repaired or looked at, or sometimes it needs tuning, or sometimes they just don't know how to put it together. Like they're enthusiastic and they just bought it, but they don't know how to put it together. And then there is a solar program where we do solar astronomy on first Sunday of every month. So we did run that virtually too for some time. So ton of outreach programs, ton of opportunities. We would love to have you come in person and, join forces with us. And
absolutely.
Well, we can chat more about that. But just if we want to wrap up, if anybody has any questions, I want to make sure they get a chance to ask that. So any last questions?
I was just going to add that the public opportunity that we were able to continue during COVID is the binocular
Oh,
stargazing.
yes.
And that's with open space also.
Mhm.
And because everybody brings their own binoculars and they're nicely spaced, we were able to resume that program.
Yeah, yeah. And that recently got a shout out in OSA's monthly newsletter as well. And that's another way to get people interested and started in astronomy, because binoculars are low investment and you can see a lot with those. So that's definitely another way to go about it.
That's amazing. Yeah. Nice to know a little bit more about your organization.
Sure. Any other questions? Okay, well, we will keep our eyes out for those asteroids and maybe help Pranvera in her research someday. So thank you so much for joining all of you today. And thank you, Pranvera, for a great talk and very inspiring talk indeed. So thanks.
Oh, absolutely. It was my pleasure. Thanks everyone for coming here and being here and, you know, watching this presentation, and definitely looking forward to hopefully cooperate with your organization and do outreach events together. I always love doing it. So just let me know when and I'll be there.
Sounds good.
Great job.
Thank you so much.
Yep, I'll just end this live streaming now real quick before we drop off Zoom. Bye everyone.